Yeah.
Where was?
I think you were right there, right? Or no? I mean, I can't remember. I think you were near the front, if I can remember correctly.
No, I think that I was.
Was Emiliano sitting next to you? Do you remember?
No. Laura Vélez is
Laura Velez. Maybe you were sitting over there then? I can't
like
remember.
how
Hold on a second. There's a lot of things that's happening, and you are important, and what I need to do is important as well. Just hold on a second.
Okay, I have a question.
But just, I
It's not that
understand it.
important,
But I will answer it here in a moment. Just hold on a second. Great. Things and stuff. Hold on, please. Film photos. Awesome. And just give me. I'm doing this. I have to help Lorenzo about something. Lolo. So just give me some time, please. Nice.
So like which lesson we have today?
Hold on a second.
Today is.
Lolo. What were you wondering, Martin?
Because I got big ears.
I know. I did randomly. You stood there.
Because I have more ears.
So when it's sí.
Oh, really? No. I will.
What was the Espera. Te doy tarde.
Are you ready, though?
No. Sí, lo tengo.
You're in control. Pardon.
Where are the ones who keep for?
We picked them up yesterday.
What? I let it here.
Why would you do it?
Because I think that's
No, people. You can cross out, put 2.2. Right, quick. Yeah, just cross out and put 2.2.
Yeah, you can. Today is 1.1.
Oh, yeah. For people who are absent.
But in 2.1 we don't do nothing.
Right, so you can just cross, like for the third time now, we've said you can cross it out.
So,
That's okay. Just means you were focused on something. Breathing. We'll try to find the best thing. It'll take 30 seconds to focus. All right, our vision to be a school where all learners thrive. With a sense of purpose. Remember, thrive is doing your absolute best, like being in a situation where you are able to do your absolute best. You're not worried about stuff. You're not worried about things. You are focused and able. So, what is within your control as a student in this room to provide that? So, let's think about what are you in control? Are you in control of someone else's sleep? Are you in control of their nutrition, their physical? No. Can you accept people? Can you encourage people? Can you support people? Something like that. Think about it there. Like, what can you do? And am I going to write down, I'm going to support my friends today? No, because you need to think about the entire community. Yeah.
I will try to not distract others. I will encourage all to try. That is very important.
All right, fall 7 times, stand up 8. So this is from Japan. It's very, very old. So it's a proverb. Proverbs are those short sayings that teach a lot about the world. And so what they're trying to tell you is that every time you fall, not literally, I mean like yes, when you do fall, you should stand back up. They're talking more about life. There's a lot of things outside of our control can knock us down, right? Can get us going a different place. Or we can try stuff and fail. Right? We can try really hard and try our best and still not do well. So what they're encouraging you to do is keep going. Try it. Like standing back up, that's not quitting. Right? So their encouragement to you about your life is like, come what may, and it will. Like, you will have hard times. You will fall. Like, there's no doubt. Will you get back up? Or will you stay down? So that's what they're asking you to think about, and they're encouraging you to stand up. I also changed the color pattern. How many levels are there to knowing something? Laura.
So first,
How many levels? It's a number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Any number.
courage.
No, it's a number. How many levels? It's to knowing something.
9.
9? Great guess. It's not 9. Need somebody to help you out. Can you have somebody help you out or make another guess?
4.
4. How many?
4.
Awesome. What does temperature measure? Matisse? Sorry, that was real. Oh, now you're right there. Oh, that's not good. What's it mean?
Radiation. Convention.
Uh-huh. I want to really appreciate Matisse right now because he's going back in his memory. He's trying to think of things that connect to this. And he's remembering some words and trying, right? Is he confident about his answer? No. He's trying the best that he can. You're off. You're off a little bit. That's about something else. That's about something else later, right? But it was a really great attempt. So call somebody to help you out.
How fast particles are moving?
Yeah, what did he say?
What? How fast particles are moving?
So it measures how fast particles are moving. The faster particles are moving, the hotter it's going to be.
How particles move?
How fast they're moving, or how slow. the speed of particles. What are the three basic states of matter? Say it together.
Gas, liquid, and solid.
Perfection. What are the three ways heat is transferred? Matthias, tell us what it is. Close, yeah. Do you have your knowledge sheet? The answer's there if you want to look at it.
I have like 3 papers here. My presentation, conduction.
Conduction, convection, and radiation. Perfect.
What?
Conduction, convection, and radiation. So again, you are responsible for this. This is something to have, to look at, to think about. So this idea. You were in the nurse all day yesterday. That's what's going on. I didn't give
Conduction,
you
convection, and
convection, conduction, and radiation. What change are we making to the break? We're gonna at the end, and hopefully longer. Today's been a little bit of a struggle, but it's not that big of a deal because when do you need a break? After like really focused work. It'll be at the end and longer. So I will try and do as many breaks as possible. Like, if we get through stuff, you go on break. Does that make sense? When you need a break is when I ask you to sit there and like think and focus. I'm not going to really ask you to do that much today. So if you don't get to the break today, it's not going to be the end of the world. All right, cool. This is something else I'm trying. Again, kind of listening to your feedback from quarter one, trying to help you be a little bit more engaged in your learning. Okay, I want to give you some targets, so some things to think about and to know what's expected out of you. So like, what is success? So if we look through here, you should be able to define, so say what something means, systems, components, and energy transfer. Those three things. You should be able to do that by the end of today. You might already be able to do a couple of them. Okay, but you should be able to define those three. If you can't, that's okay. Okay, but this is a good target. Okay. Another one, when we talk about reasoning or thinking, you're going to start analyzing the functions of a system. Okay, so you're going to start that. Right, you don't have to be an expert at it, but you're going to start thinking about a system. Okay, so that's a journey. And then a skill target, you're going to develop and refine models. Okay, so this is, does the model need to be perfect and explain things? No. Should you have the ability right now to draw a model correctly, like with the pieces on it? Yes. Like to explain, no, but that has pictures, has labels, all that stuff? Yes, you should be able to do that. Okay? So things to ponder. What is a system? What does it mean to transfer energy? What are components and what are features of a model? I'll give you about a minute to answer 1, 2, 3, 4. Again, you don't need to answer all of them. Take something to think about it in. 10 minutes a long time. You have a minute, so I want you to think and write for a minute. However many you get to, that's fine. No? Do you need to know the ponder? No. I said you might know some of them. Okay, so we are kicking off with a new phenomenon. We're going to be making some observations. We're going to be thinking, right? We're going to be trying to create some wonderings about what's going on and to observe what's going on. We're also going to be doing a mini investigation. Okay? So this is the third time that I've done this. It should be the best time. The first time was a bit of a struggle. And the big reason it's a bit of a struggle is we have these nice handy-dandy thermometers. They're really cool and good. We have 5 of them. But 3 of them, the batteries don't work. So we only have 2 working thermometers, which, for lack of a better word, it sucks. Because then you have to wait and be patient and go. It'd be better if every group had their own thermometer. But that's just not where we are right now.
Do a group, 2 groups of 12.
But then that's way too, that's not hands-on enough. Okay, that's not hands-on. So, what are the expectations? Okay, we are going to be looking at, does it matter? Should I fork over the big bucks to buy a better cup? Does it matter the type of cup that I use?
Yeah.
Are some cups better than others? Do some keep things warmer longer? Do some things keep things cooler longer? This is what we're going to be starting to think about and investigate. Does it matter if I buy a Stanley cup or not? Okay. Are there other cups that are better? Are there others that are worse? Why do things cost so much? We're going to be thinking about all of this science stuff. Okay? Because it's all important. It's all about energy transfer and all this good stuff. So you probably already have some idea. You already have some idea that maybe some cups are better than others, that things keep things hot or cold, but you probably don't yet understand the invisible kind of science and particles that's going on there, and that's what we're going to be figuring out. Okay, so what's going to happen? I'm sure we can reminisce about whatever story we're thinking about later. You're going to be working with a group. Inside that group that I will choose for you, so I'm removing that stress from your life. I'm going to show you real quick what the thermometer looks like so that you can read it. Okay, you need to be able to read a thermometer. You're going to keep track, each of you. When I look at your notebooks in a few days, I'm going to look for this information. And I'm going to go, okay, where's 2.2? Okay, there it is. So an expectation is that you do this work in your notebook. If I get to your notebook and you don't do this work, then you will do this work, I guess, at your house on a different day. And that'll be up to you. Okay? So what is the work I expect to see? I expect to see you keep track of data. I expect you to write down observations and wonderings. So I will be looking for all of that. Okay? Hold on a second, I'm not finished yet. One way you could keep track of the data is this. This is a pretty simple way. Okay, you have cup 1, cup 2, you take 2 readings, and then you look at the change. So there's going to be a change in temperature, I think, after a few minutes. Okay, so this is like temperature 1 reading, temperature 2. Okay, so I'm going to go over this a little bit more. So this is the oh, it's upside down, that's cool. Better. All right, so this is the thermometer display. That is my hand. I just took this picture. Not like right now. But if we look at this, what I want you to understand is the following. Number 1, if you don't see any numbers on it, it's because you've pressed the on-off button and it's off. Okay, so then you would need to press it again to turn it on. We've had this problem. Okay, so if the screen is blank, it's off. So you've got to press on. Number 2, you should be looking for this C here because I want you to do it in Celsius, which is a degree. Like there's 2 different types of units. When we talk about degrees, there's Celsius and there's Fahrenheit. Okay, here we use Celsius. Okay, in Colombia, Celsius. In the United States, Fahrenheit. Okay, so we're going to look at Celsius. Okay, so if you see this and it's an F, what are you going to press?
Celsius.
That button right there. Okay, that's going to change it to Celsius. Okay, so you need to make sure it's Celsius. All right, this is a number. It's 3 digits. I have a digit in the tens, a digit in the ones, and a digit in the tenths. This is 19 and 2 tenths. Okay, it's a decimal point. Okay, so how would I write that on my thing? I would write, this is my temperature 1, cup 1 maybe. I do 19.2. Later, I'm going to take a second reading. And it should be a little bit warmer. Maybe it's like 19.6. I don't know. So then I need to figure out the change. How do I figure out the change? Well, how much did it go up? Went up 0.4. So plus 0.4. So delta means change. It's science for change. So you're going to be taking 2 readings. if you guys want to go out and like yuck it up and take a break now, go for it. So that everybody else is focusing to take a break later. I feel like that's fine. But what do we need to solve so that? Because if not, you guys can just go out and like hang out and like laugh and like let everybody else just kind of be quiet and stuff. Just focus. That's cool. You have my permission. So if you're gonna stay in here, you need to focus and like be quiet and do the right thing. Yep. We'll see. So you're going to take 2 readings from each cup. Like I said, there's going to be one. Let's see how many groups we're going to have. Let's figure that out right now. Since Lolo isn't here for now, Miguel, I'm going to ask you over here. This is going to be a group for you. Right here. Right now, when do you leave? What's up? You need to keep track. So when I say keep track, that's using your notebook. You need to have it. You need to have the data in the notebook, and you need to have wonderings and wonderings, observations, and data in your notebook. That's what I'll be looking for. Okay. So we're gonna go for about 5 minutes. It's probably gonna take longer because taking the temperature has taken some time for groups. So what happens is this. So here, hold on a second. You 3 are gonna work together. You 4 are gonna work together. Yeah, you 4 right here. Okay, and then 3 right here. And Simone's working right there. Yeah, you're here. Change. So is there change between the 2 readings? Yes, there is. It's either going to go up or go down. It's probably not going to stay the same. Yeah, or you can add 2. You can add whatever. Yeah, you're going to have 2. You're going to take 2 readings. Okay, so from each. This is now the 3rd time I've had this conversation. And I'm frustrated. And I just want to define it for you. When you sit in a classroom, or you sit anywhere, and you're supposed to be listening to someone, I would imagine if you are speaking to me, you would demand my attention. I would imagine. I would imagine if you were trying to talk to me and I ignored you, or I was sitting there laughing about something, you would rightfully be angry with me. You would probably think I was a pretty disrespectful person. So I want you to understand, that's what happens when people are up here presenting to you, and you sit there and you are laughing about something. Man, it makes people like really stressed. I get really stressed out. I'm like, is my zipper, like, do I have something in my head? Am I saying something stupid? Like, am I being dumb right now? Am I doing something that's bad? Because I'm not trying to be funny. And I think other people that sit around you, if they hear you laughing, they're like, are they laughing at me right now? Like, have I done something weird? Do I need to fix something? So no one is really able to thrive in this situation. Especially because if you are laughing at something that has nothing to do with what we're talking about, the correct behavior right now would be looking at me. Because so many of you crack up looking at each other. Like I talked to like 15 people today. Oh, well, when I make eye contact with them, I laugh. And that's the bottom of self-control, everybody. Like to not be able to compose yourself when something is important to you because you looked at something. Like, you need to step out. You will never have a problem with me, ever, if you're like, I need to step out for a moment. Ever. You will always have my permission. It's way better than sitting here laughing. 100%. Sitting in here laughing, you will then have a conversation with me later, which is fine, like it's reflection, I love it. You leaving to compose yourself to come back, that shows maturity. Then we don't have to talk, because you're taking care of it yourself. So you always have my permission. If you need to break, you need to tell me, go. You're obviously still need to do the learning and the work. So you got to figure that out too. But if you consistently stay in here and laugh and interrupt things, then I have to deal with that later. All right, so we're going to try and do this again. You need to keep track of your data. You can use this table. You can do a different table. It doesn't matter to me. Your table will have different numbers on it. You need to keep track. You need to observe and you need to wonder. Okay? And if you have time, which you will, start thinking about what these things might look like as a model, because you're going to try that next. Okay? So at no point should you just be sitting around talking about whatever it is you want to talk about. If your conversation revolves around the cups and the water and the temperature, great. Wondering with each other what's happening, perfect. Talking about the Columbia game yesterday or what you're going to do later today, no. Okay, that would not be appropriate. That is not expectations. Okay? All right, so what does your group need? The first thing you need to do is figure out which one person, don't do it yet, is going to go over and grab 2 cups. So you need a taller cup and you need a taller cup and a shorter cup. They already have water in them. Some of them will still have ice in them. Okay? You will bring those back to your group. I will give 2 groups thermometers. You will start taking recordings. Okay? When you have recorded the 2 temperatures, tell me or pass the thermometer. Because we only have 2. We have 5 groups and only 2. So we need to keep passing the thermometers. Okay, that's going to be really important, is the passing of the thermometer.
We tried them 2 times.
You do 1 temperature in the first cup, 2nd temperature in the second, and then pass it to a new group. Because then when it comes back to you, you'll do it again. So you want to take the 2nd reading after. You want to take it later. Yeah. Great question. Thank you.
So you go to the
No. You do 2, and then you'll wait until you get it back, and then you do 2 more. Because then there should be a change. If you do it right away, there probably won't be much change. Please.
That says 26.
I'm recording it for people who are not here. So they get to hear the whole conversation.
Oh, hello.
They're not live watching it. They're just going to be random minutes. All right. So again, we'll have a little bit more than 5 minutes because it's been a struggle for some groups. So again, we have 1 group, 2 groups, 3 groups, 4 groups, 5. Okay, so 5 groups. Again, right now, pick 1 person to go get the cups, bring them back, and let's get going. Observation.
Alejito, no viniste el día de español porque bueno, chao.
Would you ask? You guys are here. Only put the thermometer in the water. Don't put anything else. Don't put your hands. Don't put ink. Don't stick each other with the thermometer. Only put the thermometer in the water. Dewey, where's your sweater? If you would like to go and slice it like this, that doesn't take a long time. You can go and look and see. That's great. Yes, ma'am. Hold on a second. So, even if you're waiting, you should be doing stuff. As you're waiting, you should make some notices. You can touch the cups. Look at them. Great. Again, as you're waiting, what do you see? What do you notice? What are you wondering about? You can touch the cups. Don't put your hands in it. Only the thermometer. Have you done 2? Quick. Quick as you can. Yeah, noticing and wondering. So, 1 or 1 and 2. We have cup 1, cup 2, right? No, then when you do the 2nd reading, then you'll have a change. So right now you're doing 1. So what's the first? 8.5? Cool. Now measure the 2nd.
Listo, ya vas.
You're submerging the water.
Mr. Light, we already.
I mean, try and see if it works. And if not, we have to. Awesome. So pass into this one, please.
So like,
Go. There's grip tools. Here. So again, what do you see? What do you notice out front? What are you wondering about?
No, Mr. Light, it don't work.
Right, it's probably just not enough for you.
Pico, Mr. Light.
de 12 grados.
Mr. Light, how I can please.
So the lid,
Yo quiero una cuestión.
Yeah.
¡Oh, no, no! 11.9. ¿Cómo fue eso? Bueno, sí, porque ya lo sacaste. 11.9. Y era el otro.
Oh, wow.
Sí. Ah, son una prueba. Aquí era para poner los primeros notes.
Oh, wow.
Bueno, mira, ¿sabes qué? ¿Qué programa es? Soy el puta. Soy el puta. El crack. El crack. Las putas. Ah, sí, 11-3.
Just scoop over. Here, your second reading, second reading, second reading. Go to the guy, second reading. Turn around. See what you're doing. The batteries don't work. And we don't have those batteries. Really, I have two thermometers.
Fahrenheit. Ah, no, no es Fahrenheit, es Celsius. Siempre. Celsius. Da. Hola.
Maybe it's a deal. Maybe it's not the same thermometer. Okay, go cup.
Alright, okay. ¿Cuánto? Tres libros. Voy a ver estas cartas. Y una estas escuelas solamente iban 3, 2 más. No, pero
yo me acuerdo cuando fui a la...
I mean, if
uy, las
you've done this degree, you want to think about it as a model, you can. If you want to do that.
no quisiera saber.
Pues a la hora que se poncharon la entonces, veníamos allá.
La otra,
Tonight, the first attempt give me 11 points.
It's 2 different cups.
The one is here. No, pero que ya no me dijo que- ¿qué?
el de este sería.
You got it?
Solo hay dos pasos. El primero y el segundo.
And then, like, when you see notes, what do you want? Okay.
Pero hay 4 bueno,
Nice.
11. 11.1. De menos 0.1. Y aquí.
Okay, cool. And then, like, what do you notice in the cups? Is there a difference in the cups? The matter? So, 205 or 145. And then you figure out the change in temperature. What do you guys? I can't tell you what the one is the like thing. What are you curious about? So you the other one got warm and the other one got cold? Alright, back to our seats in 5. Oh! You guys got your second three, right? 3.
How many I name it that from class?
2, 1, and 0. Okay. Oops. Was there one cup that kept the water cooler? So what I mean by that, was there less temperature change in one of the cups?
The temperature.
No, I'm asking the question. Did you all notice, did one of the cups do a better job of maintaining the temperature, or did they both change the same?
One of us something that happened that it was the 11.3, and then when we do it again, it was 11.
Okay, so it changed 0.2. What did the other cup change?
Plus 1. Plus 0.1.
Oh, one whole
No,
one?
no, plus 0.1.
So one changed 0.2 and one changed 0.1.
But one rest. O sea, like, yeah.
Ah,
so
one
like,
went down.
Yeah.
Ah, one went down 0.2 and one up 0.1. Which one went down? The tall one. The tall one. That one went up more. That one went down. So for all of us, it seems like this cup, the taller cup, either kept it cooler, like it didn't warm up as much, or it even went down. Is that true?
It was my wonder. I wonder if the thing can affect that temperature.
Nice. Did anyone notice, like on some of these cups on the outside, it looks like it's wet?
Yes.
I wonder why that is. Alright, so our guiding question. The question that we're going to investigate to understand the hidden things that are going on. Because there are invisible things happening. There are microscopic things happening that we don't yet understand. Okay, so we're going to start thinking about this. So our driving question is, how can containers keep stuff from warming or cooling down? Not yet. Okay. This is our question. My wife loves tea. She drinks tea in the morning. I drink coffee. We both have something that we put it in. It keeps it hot. Why? Why does that happen? What is the invisible science down? That's what we're going to be looking at and studying about and thinking about. So the first few things we need to do is this. This is one of those alerts. We should know this. So by today, this is going to be important that you understand what a system is. You can define it. So the definition of a system is it's a group of parts, right, working together. We should know that. Group of parts.
I do it. I put something with parts.
If you want to be scientists, which all of us do, we can change that to components. Components is a little bit more official
I
or
put that
academic
to-
of a word.
exactly.
So we could just say a system is components working together. Great. Okay, so components are those parts or pieces. We also saw energy transfer. So when the temperature changed, there was some sort of transfer of energy. Something moved. Okay, so the definition for energy transfer for right now is this idea of heat moving. Right? So it's moving from one to another. You have heat moving in for some of us, you have heat moving out for others. Some of you, the particles in the water became to go faster, right? Some of them actually slowed down. Okay? When we talk about science, we only use the term heat. We don't talk about cold. Because cold is just the absence of heat. Okay? It's like particles are slowing down. Alright, so what are the components to the cup system? So talk to your team real quick. What are the components? These are both systems. What are the components that we're looking at?
Plastic,
Talk to each other. Talk to each other. What are the components?
Components are water particles, cup, and thermometer.
I3. 2.
I consider
1. I mean, I would rather the other two gentlemen get back in before you do that. 0. Alright, so some of you were saying thermometer. Isn't the thermometer a component of the system?
No!
No, why not?
Because I think it measures the system, but the thermometer changes.
This is important. Does the piece change the system? So it doesn't. The thermometer does not change the cup. It doesn't change anything about the system. So the thermometer is not a component. What's the component? The actual cup, right? The plastic, the liquid, and there's air. There's air inside the cup, and there's air outside of the cup. Okay, and the water particles. Perfect. So we have the liquid, the water particles. Yeah.
Also, like the cup with the mirror, but there's not also the energy and the heat.
I guess you could say that there are energy in there. When we talk about components, yeah. I mean, that's if you make a really good idea. You could list energy. That would be fine. Yeah. At this point, in your notebook, if you have not started yet, I'm going to give you 5 minutes. In those 5 minutes, I want you to draw a model of you trying to explain what is happening. Why in one of the cups is the temperature not changing as much, or even getting cooler, or getting less hot, or slowing down? And why in the other cup is there more particles moving faster? What's the explanation? Remember, what you need to do right now, what you should be able to do, this is kind of your level of success. You can draw a picture, you can label it, you can show arrows moving, and you can have a description. You do not need to be right. That is not an expectation, bless you. An expectation, when I look at this in a couple days, and I look at your model, and I will be expecting to see a picture, I will be expecting to see labels, I will be expecting to see arrows showing some sort of movement. You got to figure out what's moving, right? And I gotta have one brief description of what I'm looking at. Okay? That's the expectation. It does not need to be correct. We want to think about this. How is energy or heat, right? For right now, we said energy is going to be heat. How is it entering or leaving the system?
I got a question.
So how is this happening? Okay, so for some reason there's heat entering the water, right? For some of us, heat left the water. So how is that happening? What's going on? So just take a quick minute, like 4 minutes to make a model.
How it's called like this?
Condensation. So some cups have condensation on it.
I got a
So
question. I got a question.
Uh-huh.
If when the particles move faster, is that is more heat? Yes.
It's hotter. Faster are particles, hotter. Everything's there. Cup, liquid, air inside and outside. I should see that. Condensation. That's that liquid on the outside is called condensation. Water is condensing.
I don't I don't know how to explain, but this is like hot.
Well, I would need to see labels, right?
Yes.
Arrows.
It gets into here.
Let's try and do it.
And it gets here to the cup,
Uh-huh.
but this is more thick, like it's more.
Finish. Finish. I can
Like more
get this.
gruesa. And this is more gruesa, so because
hold on,
more
just give me a
gruesa, it cannot not enter like a lot of heat from outside.
Actually, no, you can close it. My turn. We will not have time to anchor because of the thermometers. Anybody know where I can buy batteries that look like this?
Circular. That's more. Show me.
$1.60. Sometimes Éxito has it?
What?
Which Éxito? Any Éxito? Oh, yeah. Oh my God, yeah.
Por eso.
Son esas que
Then it's like
parece que
Delgado.
te estás metiendo.
Delgado?
Antique is for breast.
Yeah. We're 6-1. Make sure your number's on. All right, so you should be able to do this. You should be able to. If you don't, that's okay. But at this point, you should be able to define what a system is. Do that now. This is kind of a personal, like a check for yourself. Are you able to do this? If you are, great. If not, then we got to figure out how you're going to do this.
Is it easy like 11 is squeeze?
Is it anything easy, 14?
Yeah.
Nope. How many things are easy in this world? How many? Everybody know? Which one? Whatever a baby can do is easy, right? Cry. Reflex, right? Any of our reflexes, it's easy. Things you don't have to think about. If a baby can't do it, it's not easy.
Look someone.
It's simple. It's not easy.
Look.
Because a baby can't do it. If it was simple, a baby could do it. I mean, if it was easy, a baby could do it. Like our brain is wired to learn how to talk. Talking is pretty easy. One language. But not everyone can. Alright, cool. A system is a group of parts or components that work together. This is another thing we should start to understand. This is going to be probably a little harder for some of us, but this idea of energy transfer, what does that mean?
Energy
Yeah.
transfer.
No, but he's getting it for the last one. Define energy transfer. So again, for right now, we're defining energy transfer as when heat moves from one place to another. When heat moves from one place to another. No, it's because because a particle moving doesn't necessarily mean that it's leaving one place and entering another. So you really want to understand that something's moving from one place to another. Moves from one place to another. You want to shut down his wondering and curiosity and learning. Is that what we're trying to do? At this point, we're just using like pack up and go. No, like I'm not going to make you stay out there. You're just going to go. So just relax. What are the components of the cup system? What are the components of the cup system? Cup, liquid, air inside, and air outside. So 4 different ones. One is a group of parts working together. Yeah, it's all right. What is our driving question?
You see,
What is our driving?
What is our driving question? What is that question that's driving what we're going to do, that we're going to think about and be able to answer? Not literally, but yeah, driving our learning. Water, the liquid, the cup, and air inside and outside. Water, cup, and then air. There's air here and there's air outside.
No, also the light.
So if we remove the light, what's going to happen? We don't know. Maybe. Maybe. I don't know. How do some containers keep things warm or cool? Did you fix it? And what does the Japanese proverb, fall 7 times, stand up 8 mean? When you're done, you can turn it in, put up your chair, get going. Bye. Don't give up. Persevere. Keep going. You can make sure your chair goes up, turn it in.
and Mr. Light.
Yeah. Don't give up. Persevere. second. What's that?
Actually, the light affects, you know how? Because what, then why they don't shine? They are far from the sun, that means less light, that means less hot.
Do you think all light affects liquid?
Not all, but sunlight, because it's also mixed with radiation stuff, but
I guess we're gonna figure all this out.
that
Gotta have proof. To have evidence.